While I was in here doing that simple job, two things struck me, one of which I have progressed, was to fit. Let me move things around a little bit. Concentrate on that for a second. This is a separate box which is in mid-construction, if you want. That is simply an isolator for the incoming, which is incoming is via a 6mm twin and earth. Right? Now that goes with as little bend as possible, and this is important, to this 20 amp MCB. Now this 20 amp MCB also happens to operate this socket. Deliberately hasn't got RCD on it because if I want to do testing, I don't want to see an RCD, I want to see the guts of the thing. That's why it doesn't have RCD on it. And it also happens to feed my fibre to the premises modem through this Surge Protect extension lead. Right, coming back to this thread here. Now, there's a lot of debate about this, right? Is 6mm twin and earth acceptable for an SPD box? Yes or no? By the way, that is off and that's not going to kill me, so don't worry. There it is, you see it? Now, what happens here is, really with this system, right, TNCS, only live is likely to leak to earth, because neutral is earth. It's earth right there, right? On this system, that is literally linked to the neutral, right there. Okay? So we're literally 6 inches away from the neutral bar. So if you think about it, the chances of you getting a high voltage between the neutral and earth are remote. So really you only need the one, but they come as a pair, so I thought, solid, that's what will fit, right? Now for whatever reason, when you fit one of these 6mm are fine, absolutely, right? As is the 6mm conductor to there, and obviously the neutral as well to there. But they demand that you fit a 6mm earth conductor. Right? Now this 6mm twin and earth has only got a 2.5mm earth conductor, which they say is not adequate. Now, is it not adequate because this needs a 6mm? Or is it not adequate because it is effectively classed as a 40 amp CU? Minimum definition. And therefore they're saying it has to be, which I have now inserted, right? This wasn't here last week because that was my earth conductor. This is now my 6mm earth. Straight back to the DSO terminal block. Right there. Now the other key thing is the total length of this circuit, this SPD circuit, must not under any circumstance exceed 1 meter and should be half a meter. Now, unless you put in your SPD in the consumer unit, right, your chances of getting half a meter are pretty much zero, because that means the length of the live conductor, right, all the way across, down there, all the way down to the bottom of there, back up and out to the SPD, right, length of that plus the length of the earth conductor to there. Now on this one, it works out at 900 millimetre. So your chances of getting half a metre are pretty much non-existent. Because as you see, I've got no kinks, bends or turns in this. It's all going pretty straight down there. Down. I had to go to the bottom of the box, so that's obvious, right? And then come back up. And then that couldn't be any shorter if I tried. Right? 900 millimetre. So you ain't going to get half a metre. Now whether this 6 millimetre is a necessity is very debatable. But I fitted it anyway, just to comply. So I'm going to shove this in now, and then you'll see what's going on, right? Right, I fitted the replacement SPD. It's better quality than the one I had first place, which was Chinese cheap rubbish basically, and it was too high a voltage for UC at 385. This one, as you can possibly see, is now 275. Now my typical voltage here, because I'm very close to the transformer and indeed Pursley substation, is usually 246 volts, not 230. Don't believe everything you read in the EU. It's still 240 odds. So 275 is totally appropriate. That is the theoretical voltage at which it will start to get interested and start thinking about conducting the voltage down to earth. In reality, it probably won't really do anything very substantial till it gets to about 300 volts. That's the reality. It's a slope. It's not a cliff edge, it's a slope. So these are now fitted relatively loosely, which with my hands means tight. But of course we've got to torque things these days, don't we? So 2 Newton meters is what is anticipated. A minimum for this one, a maximum for this one. So they can go to 2.5 any day of the week. They are limited to 2. Don't ask me why, but this is probably a higher quality of unit than that one. Because this is expected to handle 100 amps. And technically speaking, that isn't. Well, it might, but it's only for a couple of microseconds. It could handle 1,000 amps for a couple of microseconds. This one can handle 100 amps all day long, theoretically. Right, we're on about 1.5 Newton meters at the moment on my cheap, nasty Draper torque screwdriver, which actually works very well. With that head, I should emphasise. Always buy one of them ones. They don't slip. I don't know if you can see it that close. Worth the investment of a tenner or £6 or whatever. Right, so we're going to torque it up. Torque it, check everything. And then I'm going to go to 2. The earth, by the way, is barred across. In case you're wondering, internal bar. There's only one earth terminal. That is quite tight enough, thank you very much. Final task, and quite an important one, let's be honest, is to feed this into the earth terminal, which, unless it's something dramatically wrong with my wiring, will be safe to touch. This is what I'm trying to tighten up here. See that earth terminal? That's a DSO's one. Coming off the head there. See it? Now we've all got our favourite screwdrivers, right? That Draper one does not like this block at all. So I hear you scream, it's not insulated. I don't care, it's my favourite screwdriver for flatheads. That is quite tight enough, thank you very much. That is not going anywhere. Right, we're still powered off basically. I've cheated a bit, I've turned the breaker off. That's very naughty, I know, but there we are. I'm a very old school type person. I've done the damn things live before now, going back a bit. Now, I can see an immediate question coming out of you. Why haven't you used the Earth bus bar as the approved Earth terminal in this box? So, I've done what they want. There's a 6mm return coming off this SPD, and I haven't been naughty and cut the Earth wire off and I'm twinning it. I don't believe in doing that. That is a viable Earth going back to there. There, that you can't see because I'm not looking in the right place. There, Earth terminal on the CU, viable Earth. It's just not being used. And if you want to really ask, that is a viable Earth terminal, albeit not 6mm. That's how it's going to be done, and I ain't altering it. Right, let's put the thing back together again, eh? Okay, everything's torqued up. It's on the rail. All that needs to be done now is put the box back together. We can argue about that Earth terminal later. I'm not touching it, that's how it's staying. I don't want an Earth loop. Now, persuade this to actually go in the box, that's the next trick. Which it doesn't seem very keen to do. But go it's going to have to. It's not optional. In case you haven't noticed, it was not a very expensive box. I'm ashamed to say it only cost 14 quid. But it does the job. You can call me a cheapskate if you want. I don't care. Everything's sitting happily in there, pretty much. So we can power it up, hopefully. There we are. There's no actual lights coming out of this thing, in case you want. It's like a nodding donkey. There's a bar inside there with a low temperature melting point solder joint. If this varista, it's buried in resin inside there, fails, things will get hot pretty damn quick. The solder will melt, the donkey will drop, and that green will turn to red, hopefully, telling you that it has had it and you have to go and buy another one. Really simple stuff. Nothing technical about it whatsoever. The only technical thing about this is the varista that's buried in the resin inside. And you see those resistors in millions of things. There'll be in your computer power supply. Any decent piece of kit is going to have one of them, particularly if there's a switch mode power supply involved. So there we are. Job done. Hopefully that'll be good for 10 years. It'll probably outlive me. Good morning. This is appended to the fitment of an external SPD box to my aging non-metallic consumer unit, and I want to have a little look at how these SPD surge protection devices function. So as you can see, I have cut one open. a particularly cheap and nasty variety, this one, and the wrong voltage for my purposes. This is a 420 volt, which is no good for single phase 240 volt. You need a lower voltage than that. So as you can see, looking at the front, which is what you would see if it was in a CU or indeed an external box, is very little but a green flag window. It's a fairly straightforward piece of kit. Normally there would be two of this particular model, one for the live to earth and one for the neutral to earth. The live to earth being the most important one. There is a fairly big varistor buried in that resin. You can't see it, obviously. It's buried in there for safety reasons, because in a fault condition or a failure condition, it's going to get hot. At the end of its life, it's going to get very hot. Right, connections, there are only two. One is hidden by my crop clip there, which feeds that braid, which goes directly to the varistor inside the resin. The one on the bottom that you can just about see, there's a connector there. Again goes through a braid, but this time through this metal connection plate, we will call it, which is soldered to the post that actually goes to the varistor in the resin. There's the solder. It is, I think, wouldn't bet on it, a low melting point solder. So what happens is, I will demonstrate this in a minute, during a failure or end of life situation where the varistor has been subjected to too many high voltage spikes and is damaged by it, it starts to overheat because its resistance at all levels is dropping. So it's starting to pass current that it shouldn't really be passing. This heat is sensed by the solder joint, and once it gets hot enough, that solder joint will melt and break. This is to stop basically the whole thing going on fire, because if you keep the current flowing, this casing will eventually melt. Something you don't want either in an external box or, even more importantly, in the middle of your consumer unit. So what I'm going to do, I'm going to put a hot air gun on this and demonstrate, albeit by cheating, how this actually works. Okay, so what I'm doing now, I'm mimicking end-of-life failure where the varistor is overheated inside that resin block. Okay, now the current is obviously passing through that plate, and the ambient temperature is also affecting that plate, so the solder will eventually melt. Now this is a hot air gun used for SMD work, and I've got about 300 degrees C on this, and if I'm patient enough, it should trigger end of life failure. I don't know how patient we're going to be like. Obviously it's a fairly big plate, so there'll be some thermal inertia before it gives way. There we are. You see that plastic case was actually starting to melt there. Now, I must admit, the first time this happened, okay, I was not satisfied that there was enough of a gap there after failure to prevent arc over. It was quite close. I've actually chopped a couple of mil off of this plate before I resoldered it for our purposes. So you can imagine the gap was about 2 millimeter less than what it is now, and I don't think that's acceptable. At the end of the day, circuit's been broken, So everything cools down, and if I can show you if it worked, which this thing is pretty rubbish, I must admit. That should now be a red mark, but it's sort of half green and half red. When I fitted an external box to my CU for an SPD, I chose a 2-bay one, so there will be two side by side, as you will see in the video, right? One for live to earth, one for neutral to earth, which is all fine and dandy if you've got enough room for 2 bays. Obviously you put in a separate box, you do. If you're trying to fit this thing into an existing consumer unit, which is normally pretty well packed, because inevitably things are added on over time, then you might not have room for 2. So that's where this comes in. It's exactly the same idea, but there are 2 varistors buried in the resin that you can't see because I haven't destroyed this one, because it's a better quality one, okay? And it works at the correct voltage for single phase. So here you've got 2 varistors in there, and both live and neutral share the same package. One thing I must point out, and it's really, really important, is that this bottom fitting on the DIN rail is not for a live terminal. Absolutely not. You see, PE, protective earth, it has to have the 6mm earth in there. So what that means is, if you want to fit this in a consumer unit, you usually have to cut off the lug on the bus bar, because you don't want the live lug going into the earth terminal, which would be possibly dangerous and definitely pointless, because then you've got both of these going to live. So live's going to live and neutral is going to live. So a bit of a waste of time, and definitely not what you want to be doing, trust me. So if you're going to put this in a CU, you're going to have to cut the bus bar lug, so that does not get the live bus bar terminal, it gets a 6mm earth cable. Most important. What you say about having 2 in one package? I don't know, a bit less thermal isolation. Apart from that, probably ideal. Very little is going to go from the neutral to earth on a normal combined systems, pen systems, because neutral is effectively earth. So the live to earth is the main asset of this unit, to remove spikes on the live above a certain voltage. You're unlikely to get high voltage on the neutral because it is inherently tagged to earth at your premises, at your feed-in, your DNO feeding. That's where your earth becomes neutral, literally. So nothing wrong with fitting these, as long as you've got room in the box and you're prepared to cut the bus bar lug, which means you can never put a bog standard MCB in there again, because there won't be no lug to hold it in place or to connect it. I just want to show you that you can test these SPD units. Obviously you're looking at the varistor buried within, without destroying them, with a cheap nasty mega. Because for safety reasons, all megas have a very restricted current output, so you don't get fried when you're using them. Or at least that's the general idea, though I wouldn't recommend trying to test that out if I were you. So obviously this particular SPD has an entry voltage level of 275 volts RMS AC. Okay, so below that voltage it shouldn't be interested whatever in what's going on. So if we start ramping up the mega at 250, it should be no response whatsoever. But what happens when we go to higher voltages? Well, let's find out. Now here's 250, okay, here's me pressing the test. It goes to infinity, so it's not passing current, right? 500, it is 0.5 meg, okay? I'm trying to get this thing to stop. It doesn't want to. Right, 1000.2 of a meg. Okay? So you can see as you're going up, the voltage level being applied. Bear in mind it's DC, but never mind, we won't tell anybody that. It's starting to pass some of the voltage through the varistor, which is exactly what it is designed to do, to get rid of high voltage spikes. So you can sort of test if your varistor is working by using a simple mega. And because you're only putting a microamps across it, you ain't gonna fry it.